Hello, I'm Dr. Levon Hairapetyan, a business professor at Houston Baptist University. In this video, I will continue chapter 9, which deals with predictive data mining. So in my previous video, I demonstrated how we can use k-nearest neighbors method for classifying categorical variable data and for estimating the value of continuous numerical variable. In this video, we will learn about another tool called classification trees, and which also can be used to classify categorical data. Later, we will learn regression trees, which will be used to estimate the value of continuous variable. So the abbreviation CART, stands for classification and regression tree. So the essence of this, I will talk about both of them, but the essence is the same, just the way how they split is different. So the essence is that the entire data set successively partitions into subsets in such a way that each subset is more homogeneous. So during each step, the entire set will be divided into subsets based on the value of a single variable. And those, again, the essence is to divide in such a way that each subset will be more homogeneous than the entire set before splitting. The measure which we will use for is called impurity. So impurity, in other words, we will at each step in creating decision tree, the entire set will be divided into two subsets in such a way that, that the impurity will be improved. How impurity is measured? So impurity is measured for classification trees is measured one way, and for a regression tree, which we'll discuss later, it will be a different way. But today about classification tree. In classification tree, the impurity of a group is the proportion of observations within that group which do not belong to the same class. For example, if all observations in the group belong to the same class, then impurity is 0. Another example I have here, let's say if we have 7 observations in the group, and 3 of them belong to class 0, and the rest is class, actually no, 7 observations group belongs to class 0 and 3 to class 1, which means we have 10 observations. So obviously these 3 observations do not belong to the right class. So impurity will be 3 over 10. So 3 is number of objects which do not belong to the same class, and 10 is total number of objects in the group. So now we will learn how we can create a classification tree, and then we'll learn how we can use classification tree to classify a new object. So I will start with an example which is not from the textbook, but this is much simpler example and to explain the essence of classification tree. Here's the example. A bank customer applies for a loan and file out a form. So according to information, customer is 39 years old, unmarried male who owns a house and has 34,000 income. The question is, shall the bank approve the loan, or it's too risky to approve it? In order to make that decision, the bank manager checked the bank's credit data for some 10 customers. And based on that data, they create a classification tree and they decided whether to approve or disapprove the loan. So this is the information about those 10 customers. So these are the actual 10 customers. And so the first customer, age 36, married and does not own a home, it's male, and the annual income is 52,000 and did not default on loan. And similar information for other 9 customers. So based on these 10 customers' informations, we will create a decision tree and then, not decision, classification tree. And then we will use that classification tree to classify this new customer, either default or not default. How we will do that? Let's, here I specified that the basic idea is very simple. We try to find an informative test which will split the observation into 2 new subsets with less impurity. So let's make some observation about this data right here. If you look carefully at that data, the first observation, if we don't use any test to make a decision, which means if we don't look at data at all, we just guess whether prove or not prove the loan, then there is a 50% chance that our decision will be correct. 50-50 because we are not using any information. Now, second observation. If we look at data carefully, then you will see that 60% of male customers have defaulted and 60% of women have not defaulted. Which means if we know the gender of the applicant, then we can improve our decision. So if we know that the person who applied is male, then we will reject. If it's female, then we will accept. In that case, our accuracy will increase to 60%. So better than when we don't use any data at all. Now, the third observation, again, if you look at carefully at the data in that table, is that those 3 applicants which have above 36,000 annual income had a good loan. So 3 with the more than 36,000 income has good loan, so they didn't default. And 5 out of 7 applicants with below 36 had bad loans. So therefore, if we know the annual income, then we can estimate or classify new customer, and our accuracy will increase up to 80%. Because if the customer's annual income is more than 36, we will approve the loan. If it's less than 36, we will disapprove the loan. So in that case, we will be correct 8 out of 10 cases, which is 80%. So this is the way how this classification tree is constructed. So based on the historical data we have, when I say we have, actually in this simple example, we were able to figure that out manually, but when you have a huge data set, that's what software will do, and there is a heavy math behind it. But the concept is, that's what I want us to understand. The concept is that we have to find informative test should be found, which will split, say, the data set into 2 subsets with less impurity. And we will continue this process, splitting set into 2 subsets until we will go up to the one object in a class, which means impurity is 0. So this is the classification tree for that example. Let me explain how this is created. So first, the income is compared. If the value is 36 or less, we go this way. If it's more than 36,000, we go this way. So if it's more than 36,000, then we approve the loan, because based on the information, there were 3 people, three customers which meet this condition, and all of them had good loan. So impurity here is 0, because there will be no observation which does not belong to this class. Now, if the income is less than 36, and there are 7 of them, then the next test now we will divide these 7 into 2 new subgroups. So if it's less than, the age is less than or equal to 36, then there are 4 of them, and all of them defaulted on loan. If it's more than 7, there are 3 people, and for these 3 customers, we will check the marital status. If person is not married, based on our information. It's default. If it's not, if married, they're not default. So this is the classification tree created based on this data table, data about 10 customers. Now, let's remember what we're trying to do. We're trying to classify a new customer using this classification tree. So our customer, new customer, these are the information. This is the same information which I got from here. Where is that? Right, this is the customer in one of my previous slides. 30 years old, unmarried, owns a house, and income is given. So I have the same information here. The new customer, age is 39, marital status not married, gender male, owns a house, yes, and annual income is 34. So how do we classify this new customer using classification tree? The technique is called dropping down the customer or observation through the classification tree, starting from the root of the tree. So our customer, first we compare whether the income is, compare with the 36. Income is 34, therefore it's less than or equal to 36. That's why we come this way. Then we compare age, and age person is 39 of age, therefore it's more than 37. We go this way. And then we check the marital status, person is not married, so we go this way. And we ended up in this node, which is a bad loan, which means this means that we end up in here. Therefore, bank, based on the information available, based on the information from those 10 existing customers, bank will reject or decline the loan application because there is a chance that the person, big chance that the person will default on the loan. So this is how classification tree is created and how we use classification tree to classify a new observation. Very short summary. In order to create a classification tree, we start with the entire set and then we divide into two subsets based on the value of a single variable. And this, the division in that simple variable and the value is selected in such a way that when we divide, these two new subsets will have less impurity. And then we'll repeat this process for those subsets. So we divide each subset into two new subsets based on the value of another variable or maybe the same variable, and so on. So this is how decision tree is created. And when decision tree is available, then if we want to classify a new observation, what we do, we drop down the new observation through the decision tree and to see where we end up. And wherever we'll end up, it will be the class 0 or class 1, and that's will be the classification of the new object. So now in a few minutes, I will classification tree, create classification tree in Excel, actually using analytics solver, using this Hawaiian ham company. We'll talk about this. This company develops software that filters spams, and it has information about more than 4,600 email messages, and they are classified. These are the actual email messages, and they are classified either class 1 or class 0. Class 1 meaning spam, class 0 meaning not spam. And we will create this in analytics solver soon. But now I would like us to look at the classification tree which is presented in your textbook and which is based on a small subset from this file. And they took only 46 items for this, basically 1% of all items. And the tree which they created based on the frequency of 2 characters used in the email: exclamation mark and dollar sign. So this is the tree which you can look in your textbook as well. So, and in circles, what you see, this is the frequency, the value which we will, or the variable which we will use to split here is dollars, the frequency of dollars. And this says that if the frequency is less than or equal to 0.0555, we go this way. Or it's the same as if the percentage of dollar signs in the email message is less than 5.55, we go this way. And there are 28 of them. Remember, 28, they use only 46 in this example. And then here, another frequency, but this frequency is about exclamation mark. So if frequency is less than this number, we go this way. There are 21, and if it's more, then we go this way, and so on. Now let's use this classification tree to classify an email. Let's say a new email arrived, and it contains 5% of dollar sign symbols and 5.5% of exclamation symbols. So do we classify this as a spam or not spam? 5%, or which is 0.05 frequency for dollar sign, and 5.5 means, which means 0.055 for exclamation symbol. Do we reject or do we classify this as a spam or not spam? In order to answer that question, we have to drop this email through this tree. So and we'll start in here. So we have to check the frequency of the dollar symbol, and the frequency is 5%, which is 0.05. This 0.05 is less than this number, because this is 0.0555. So we come this way. Now he will check frequency of exclamation symbol, and it's given that 5.5, which is the same as 0.055. 0.055, actually, 0.0, yeah, it will be this way. We're coming this way, and then we compare with this symbol, 0.55, and then it's more than, so we move this way, and then it's less than this number, we move this way. Therefore, we have to decline this, or not decline. Okay, there was one typo in here. I removed this point. It was 55%, not 5.5. So let's do one more time. So dollar sign, it's 5%, which is 0.05, which is less than this number. So we go this way. Then we compare exclamation frequency. Frequency here is 0.55. So it's more than this number. We go this way. The same, now we are checking again the same, pay attention, the same variable is used in 3 different splits here. We compare this 0.55 with this number, it's more than 0.26, we move this way. And then we compare this 0.55 with this, which is 0.56, obviously it's less than 0.56, we come this way, and we end it up right here, which means when we have to classify this email as class 1, which is spam. In order to identify a good classification tree, sometimes we prune the tree. It's called pruning the tree. And the pruning tree is basically, the essence is by removing, if I want to prune tree in here, so I will remove this entire subtree and I will replace this subtree with just one node. And how we will do that? So look here. So here, if I want to remove this, pay attention. I have two observations which belong class 1 and one observation which belongs to class 0. Therefore, 2/3 of all observations in this subtree belong to class 1. Therefore, after pruning, we will define this as a class 1 because class 1 is dominant. It is more than usual or commonly used cutoff value, which is 0.5. And so what we did, look here, we just replaced this subtree with one node. Now let's do classification tree in using analytic solver based on the file called Hawaiian Ham. And here what I will do two things. First, I will do the classification tree, but in addition, I will also use the classification tree to classify new objects based on that tree. So everything which I will do is written in this appendix 9.4, and this file is posted on the Blackboard, and I am asking you to do all steps, and except before clicking finish, we will do 2 new steps, and these 2 new steps are in order to be able to classify new observations. It's not done in the textbook, but I think it's very important to not just to learn how to create the tree, but the ultimate goal is to use the tree for classification of actual new objects, and that's what we will do. So let me switch to my file. So this is the file. So each row here is related, contains information about a single email, and there is lots of information. These are all like lots of percent of credit, 0% money, lots of information. And one more thing which I want to emphasize is that this is already partitioned, and the way how it is specified in which set they are in the training, validation, and so this last column specifies that partition effect. So T stands for testing, for example. Now this will, remember with this standard partition, this variable, which means this value specify how this file is partitioned. So this file is already partitioned. Now what we will do, we will go to data mining and then classify, and we will use classification tree. We will use the following variables. We'll start with percentage, which one? Let's start with semicolon, or from here. I will select all this up to here. So these are the variables which we will use for classification. There are tons of variables. We don't have to use all of them. We can use as many as we want. So in the example which is presented and in that appendix, these are the variables they are suggesting to use. I'm selecting these here variables. So starting the semicolon up to total all cap. Then I have to specify what will be my output variable. Remember, we want to classify whether it's spam or not spam. So spam variable will be my output variable. Then here we will have 2 classes, like class 1 and class 0. Class 1 means spam, class 0 means no spam. This is cutoff. Default is 0.5. I will keep the same default. And then we'll go next. So first we have to tell how the partition is done. So we'll click on this partition data. Check this box. Since our data I showed you, it is already partitioned and we have a variable which contains that information about partitioning, I'll check use partition variable. And here I'll go and select that variable. And that variable is standard partition. As you remember, I showed you. It was the variable in the last column. And then done. So we did this part. Then here I'll check default is they are asking record the terminal loss to under 31. And then here we'll use, this is just default value, I'll keep the way it is. Prune, and using validation set. And then well, we want to select which type of tree, pruned tree we want. We want to get the best pruned tree. Done. Then, so the suggestion is to select this show future importance, and then maximum level I will leave the way it is. And then tree to display. Which tree do we want to display? Click here, and okay, let's select this tree. Fully grown, best pruned, and minimum error. Done. So we're done here. We provided all information. Now we'll go next. He will specify which summary reports do we want to see. You can check as many as you wish. I just checked summary report for training set, for summary report for validation, summary for test. This is the important part which is not done in appendix. And this is what you have to pay more attention, because this is not described in the notation, but this is described in my slide, and I will demonstrate here. And the reason here is that I want to not just get the tree or trees, but use it to classify new data. And I already have new data. Click. Then my new data is in a separate file, and I will go to and Excel files are, as you know, it's called worksheet. So I'll go here. Oh, it's workbook, not worksheet. I was clicking the wrong place. So this is my data. So see my new file. This is the file with new data. I created this artificial file. So these are about how many? 14 new emails, information about 14 new emails. The only thing which is missing, we don't know whether these emails should be treated as spam or not spam. So that's what we're trying to do with the help of Analytics Solver. We will click variables. I use the same names which are in the original data. So I'll just click match by name, and matching is done. And I'll just click finish. And so Analytics Solver created lots of tabs, new tabs. And so trees, there are best tree, minute. Actually, when you click and you don't see tree, then you go to data mining, click on the model, and wait a little bit, and tree will show up. So this is the tree. This is the full-grown tree. We will not go over these branches because that's what software did. For each the new data, and we had 14 of them, so it will run or drop through the tree and figure out whether it should be interpreted or classified as spam or not spam. So this is the best trimmed tree. And this is the best tree with the minimum error. And there are several scores, like for testing, for validation, for training. If you click any of them, you will see familiar things. So confusion metrics for training, for validation, for testing sets, and not only confusion metrics, but also lots of other matrices like overall error, accuracy, specificity, sensitivity, and so on. But the thing which I want to pay attention is this new score. This is what we were expecting to get. Remember, we had 14 new emails, and our goal was to use classification tree to classify each of them either spam or not spam. So software did it, and this is the result. Therefore, the first email should be treated as spam, second spam, third one is not spam, fourth is spam, and fifth is spam, and this is spam, and the rest are not spam. So this was the ultimate goal, to be able to classify new emails, either spam or not spam, and we did it using analytic solver. Let me switch to. So this is what I did, and these are the two steps which I said it's not in the appendix, but you have just carefully read this when you redo this example. So this concludes my lecture about classification tree, and next time I will do regression trees. Have a nice day. Bye.